Hello, my dear students. Welcome to IMS Gate Academy Gate Score Booster session on communication system subject. So, in this particular session, we are going to discuss the variety of questions which are very much helpful for your coming gate exam. And this particular subject is common for two branches, EC and instrumentation. So, all of you kindly share this video link with all of your friends so that they also will attend this session in live and they also will get benefited from this particular session, right? So, in this particular session, I am going to discuss the variety of questions. So here, as I mentioned, variety of questions. Okay, so here the question type, it can be either MCQ or it can be NET or it can be MSQ. And interestingly, I will discuss some questions which are conventional type also. Okay, so here the main agenda of this particular session, whatever the concepts we are discussing, whatever the questions that we are solving in this particular session, those are going to help for your coming gate exam, right? So in this particular session, I am going to focus on the first three chapters of communication subject. Those are introduction and amplitude modulation, and then angle modulation, and then AM and FM receivers, right? So tomorrow we are having one more session. In that particular session, we will discuss some more interesting questions regarding the remaining chapters, right? So I hope the agenda of this particular session is clear for everyone. So all of you quickly share this video link with all of your friends. Okay, we'll start. I hope all of you are eagerly waiting for the session. So let us start. So this is the first question. This here in this particular question, I have mentioned regarding the amplitude modulated wave. Okay, here one assumption is there, Ka into AC equal to 1, where Ka is nothing but amplitude sensitivity and AC is nothing but carrier amplitude. Okay, so the product of Ka and AC is 1. And here in this, you have to consider this waveform regarding amplitude modulated wave. And here we have to solve this question in two cases. Okay, so first case, here how much value we need to add to the earlier carrier amplitude so that we will get the modulation index as 0.1. Whereas in case 2, for what value of carrier amplitude we are going to get the modulation index as 0.1. So the wording is very interesting. It is very important. Whenever you are attempting any question in the gate exam, according to the context, the answer will vary. Okay. So both the questions requirement is same. That means in order to get modulation index as 0.1. But with respect to case 1, the wording is in one way. With respect to case 2, wording is another way. Right. So all of you give a try. Whatever the answer you are getting, you can mention in the chart. I will give some time for all of you. Okay. You can take the screenshot of this particular waveform and you can try for case 1 and case 2. Whichever case you are comfortable, you can try first. After that, you can do for another one. Yeah, this is a very interesting question. All of you give a try. So here in this particular question, you're having the amplitude modulated waveform like this. So for this question, you have to consider this assumption and you have to solve this question case 1 and case 2. The ultimate requirement is same, but according to the context, you have to mention the answer accordingly. All of you give a try. Yeah, time up. Okay, whoever tried this question, what is the answer you are getting correct? Okay, what is the answer you are getting after solving this question? You can mention in the chat. And whoever solving this question, whoever watching this particular session later, right? So after solving this question, what is the answer you are getting? You can mention in the comment section. Okay, right. So here, if you observe, here in this question, I have given one amplitude modulated wave. Okay, so that means it is a combination of carrier signal and message signal, right? So if you know the formula, directly you can solve this particular question. Whoever not having the enough knowledge regarding the formula, so I am giving the brief introduction regarding the formula. Okay, what are the formulas that we are going to use here whenever you are having amplitude modulated wave? How to find the modulation index or how to find the carrier amplitude. So for that, I will give the derivation so that even if you are able to remember the formulas directly you can solve this question. But due to any reason, if you forget during the exam, no issue at all. You can get the formula, you can do the derivation in couple of minutes. You will get the formula and after that you can substitute the values. Okay, right. So for the timing here, whenever you're having amplitude modulation wave, I hope all of you know the standard equation regarding AM signal. Regarding AM signal, the standard equation in time domain is S of t equal to AC into 1 plus Ka M of t into cos 2 pi fct. So here actually AC cos 2 pi fct is nothing but carrier signal, right? So here also if you observe, regarding the carrier signal, see when you're having time is 0, you're having peak value. So that means it is a cos signal only. Okay. And here in general regarding message signal, you can consider sine signal or cos signal. But can you observe regarding the envelope, just by observing this particular signal, can you identify whether it is sine signal or cos signal? Yes. See, here if you observe at t equal 0 instant, you're getting peak. So that means it is cos signal. Cos signal. Whereas for sine signal, its value will be 0. Okay. So in this particular waveform, we have considered message signal also cos signal only. Okay. So here AC into 1 plus Ka, just like carrier signal we have considered AC into cos 2 pi fct. Similarly message signal we are considering as AM cos 2 pi fm into t. AM cos 2 pi fm into t. Into, you can multiply with the carrier signal cos 2 pi fct. Okay, right. Now Ka into AM. Ka is nothing but amplitude sensitivity and AM is the peak amplitude of the message signal. When you do the product of those two, we are calling or we are considering this overall product as modulation index mu. So now we can represent this equation as AC into 1 plus mu cos 2 pi fm into t into cos 2 pi fct. Okay, right. So if you are having one simple equation like AC cos 2 pi fct, so that means for this particular cos 2 pi fct, the peak value is AC. And here cos signal varies with respect to time. Okay, right. Similarly here, you are having AC into 1 plus mu cos 2 pi fm into t into cos 2 pi fct. So for this overall signal, if you observe, this is the peak envelope of the AM signal. Peak envelope of the AM signal. Okay. So from here I am writing peak envelope of AM. Peak envelope of AM signal. So which is nothing but AC into 1 plus mu cos 2 pi Fm into T. Right? I hope it is clear up to this point. Now, here if you observe, whatever we have represented, that is nothing but this peak envelope. Okay, right. So in this peak envelope, you are getting the maximum value and you are getting the minimum value. Maximum and minimum. Okay. So in between it is varying. Now, here I am writing the maximum value of the peak envelope. In which case you are going to get the maximum value for the peak envelope of AM. See, here AC is the peak amplitude of the carrier signal. It is a constant. Here modulation index is a constant. Okay. Here if you observe, regarding cos 2 pi Fm into T, it is the variable. In general, cos signal will vary between -1 to +1. Okay. So if you want the maximum value, that means cos term value you have to consider maximum. That will happen +1. Okay. So that means here Vmax you are going to get AC into 1 plus mu. AC into 1 plus mu. Okay, this one you can label as equation number 1. Similarly, you are going to get the minimum value regarding the peak envelope of AM. Okay, so here minimum value you are going to get when you are considering cos value as -1. So that time you are going to get AC into 1 minus mu. AC into 1 minus mu. Okay, right. Now you got two equations regarding the positive envelope of AM. We are getting maximum value and minimum value. Now you can take the ratio of these two. Take the ratio of 1 and 2. So here left hand side you are getting Vmax by Vmin. Vmax by Vmin. On right hand side, AC term will get cancelled. You are getting 1 plus mu by 1 minus mu. 1 plus mu by 1 minus mu. So from this equation, our agenda is to calculate modulation index. Okay, I hope you might have studied regarding componendo and dividendo operation in the maths. Okay, so whenever you are having ratio of two numbers like this or fraction of two numbers, okay, fractions like this on left hand side and right hand side if you are having, in order to do the simplification, okay, you can perform whatever the operation you are performing on left hand side, similar operation you can perform on right hand side. Okay, so for the time being I am applying componendo and dividend rule. So by using that one, here say for example on the left hand side I am performing the subtraction operation. Say for example I am subtracting denominator term from the numerator. Okay, similarly in the denominator I am just adding both. Now whatever the operation you have performed on left hand side, similar operation you have to perform on right hand side. Okay, so here left hand side I have performed the subtraction operation. Similarly here also right hand side you have to perform subtraction. Okay, so we have to subtract the denominator term from the numerator. Similarly here I have performed addition. Similarly you can perform addition here. 1 plus mu plus 1 minus mu. Say for example in the numerator if you have considered like addition, here also addition. If you have considered subtraction here, similarly subtraction. Okay, what is the operation here you are considering? Accordingly similar operation on the right hand side. Okay, right. So here -1 and +1 will get cancelled. Then here minus mu plus mu will get cancelled. Minus of minus is plus. Okay, mu plus mu is nothing but 2 mu divided by 1 plus 1 is 2. So here 2 will get cancelled. You are getting modulation index mu. So from here we can write modulation index mu as Vmax minus Vmin divided by Vmax plus Vmin. This is the modulation index formula. This you can use whenever in the question, if you are having amplitude modulated wave. So directly from the amplitude modulated wave, how to calculate the modulation index? This is the formula. Vmax minus Vmin divided by Vmax plus Vmin. With the help of this formula, you can calculate the modulation index. Okay. So similarly, just observe Just observe the previous equations 1 and 2. Can we calculate? See, as of now, we got the modulation index formula like this. Okay. So, if you want to calculate AC value, whatever the mu value just now you got, you can substitute in equation 1 or equation 2. Accordingly, you can find AC. That is one approach. Now, if you want to get AC value in easy manner, what you can do, just observe these two equations on the right hand side. Just observe the equations on the right hand side. From that, you are getting one clue. Okay. So just perform addition operation. What you are going to get? Just perform addition of 1 and 2. What you are going to get? So on the left hand side, just perform addition of Vmax and Vmin. On the right hand side, AC into 1 plus mu. AC into 1 plus mu. So we are expanding. AC plus AC into mu. Okay, plus. Vmin is AC into 1 minus mu. Expand it. AC minus AC into mu. Here plus AC mu minus AC mu will get cancelled. AC plus AC is nothing but 2AC. AC plus AC is nothing but 2AC. So from here we can write AC equal to Vmax plus Vmin divided by 2. Vmax plus Vmin divided by 2. Okay. So whenever you are having amplitude modulated wave, so from the envelope you can observe what is the maximum voltage, what is the minimum voltage. With the help of those two, you can calculate the modulation index. Similarly, with the help of those two, you can calculate the carrier amplitude. Okay, I hope all of you are getting the clue. Now these are the formulas. If you know these two formulas, directly you can solve the question. But whoever not having the knowledge or regarding these two formulas, or whoever forgetting these formulas due to any reason, so that is the that's why I have explained the procedure, how we are able to get the formulas for modulation index and the carrier amplitude. I hope it is clear for everyone. Okay. So here this is the given waveform regarding amplitude modulated signal, right? So just observe this particular signal. Can you tell that, just by observing this waveform, can you tell that what is Vmax and what is Vmin? All of you quickly mention in the chart. What is Vmax and what is Vmin? Just by observing the diagram, you can easily tell. See, this is the envelope on the positive amplitude axis, right? So among these voltage values, here you are getting the maximum voltage value, right? So Vmax equal to 10, Vmax equal to 10, and here Vmin is 5, Vmin is 5. Okay, so the modulation index formula, just now we have mentioned Vmax minus Vmin by Vmax plus Vmin. So directly I am writing 10 minus 5 divided by 10 plus 5. So 10 minus 5 is 5, 10 plus 5 is 15. So you are getting 1 by 3. 1 by 3 means 0.33. But here if you read the question, here our requirement is 0.1. In order to get modulation index as 0.1. So for the given waveform, we got the modulation index as 1 by 3, which is nothing but 0.33. Okay, right. Now, can we calculate AC? Yes, we can calculate by using this formula. Just you have to take the average of these two. So 10 plus 5 divided by 2. So 10 plus 5 is nothing but 15 divided by 2, which is nothing but 7.5. See, if you want, you can consider units like volts. For the timing, whatever the waveform here we are having, we can consider it is a voltage waveform. Okay, right. So since you are performing ratio of two voltages, obviously there won't be any units. It is a constant. Okay, right. So here we are having 7.5 volts. So for the given waveform, the modulation index we got 1 by 3. For that, the carrier amplitude is 7.5 volts. Okay, 7.5 volts. Okay, now we have to find out the new carrier amplitude with respect to case 2. With respect to case 2 of the given question, you have to find out the new carrier amplitude in such a way that in order to get the modulation index as 0.1. Okay, so before discussing that part, for the Same, whatever the time domain equation we have considered regarding AM signal, here I have given one approach, how to find Vmax and Vmin. Now I am giving one more approach also, one more approach. So here, what is the first equation we are having? You can consider once again as it is regarding AM signal, S of t equal to AC into, okay, whatever we have explained here, that is the first approach. Now I am giving the second approach. S of t equal to AC into 1 plus Ka m of t into cos 2 pi f c t. Cos 2 pi f c t. Right. So just multiply AC with both the terms. From here what you will get? AC plus AC Ka m of t into cos 2 pi f c t. Now, if you read the question carefully, in the question it is mentioned one assumption. Ka into AC equal to 1. Ka into AC equal to 1. Now here you are getting AC into Ka, so this term we can consider as 1. Okay, so from here what you are getting? AC plus m of t. AC plus m of t into cos 2 pi f c t. So from the given waveform, m of t is nothing but, it is the cos signal. For the time being I have considered like am cos 2 pi fm into t. So now you can substitute in place of m of t. So from here you will get AC plus am into cos 2 pi fm into t into cos 2 pi f c t. Cos 2 pi f c t. Okay, just like here. Earlier we got the expressions in terms of modulation index. Okay, but here now you will get in terms of AC and AM. Okay, right. So just like here, the peak envelope of AM, which is nothing but this entire term is nothing but the peak envelope, right? So AC plus AM into cos 2 pi fm into t. Now just like here, we can find the maximum voltage and we can find the minimum voltage regarding the envelope of AM, right? So directly you can write Vmax and Vmin. All of you please respond what you are going to get. Here in this case, what is Vmax, what is Vmin? Here, when you are considering cos values plus 1, then you are getting maximum voltage. So that is nothing but AC plus AM. Similarly, when you are considering cos value, minimum value, that is minus 1. Sometimes students will consider minimum value of cos signal means 0. But in general, cos signal or sin signal varies between minus 1 to plus 1. Whenever you are having negative values, obviously the negative maximum will be the minimum, right? Whenever we are not getting negative values, obviously 0 will be minimum. But regarding cos or sin, you will get minimum value as minus 1. Okay, right. So here, when you are substituting minus 1, you are getting AC minus AM. AC minus AM. Okay, right. Vmax you got like this, Vmin you got like this. Now, whatever the operation earlier you have performed, similar operation you can do, or otherwise, since you already got the modulation index formula here, now whatever Vmax, Vmin you are getting, okay, so that you can substitute. Whatever Vmax, Vmin you are getting, you can substitute now. You are going to get one more derived formula regarding modulation index. Now, in this formula, if you are substituting regarding modulation index, Vmax minus Vmin divided by Vmax plus Vmin. In this formula, just substitute Vmax and Vmin. Vmax is AC plus AM. Vmin is AC minus AM. Vmin is AC minus AM. Similarly, you can substitute in the denominator AC plus AM plus AC minus A. Now, AC will get cancelled. Here, AM will get cancelled. Minus of minus, it is plus. Minus of minus is plus, right? AM plus AM, that is nothing but 2AM. Here in the denominator, AC plus AC, that is nothing but 2AC. Here 2 will get cancelled. From here, you are going to get AM by AC. So this is one more derived formula regarding modulation index. Okay. So modulation index mu equal to AM by AC. Modulation index mu equal to AM by AC. So this formula we can use whenever this assumption is there. AC into Ka equal to 1. So in this question it is mentioned AC into Ka equal to 1. Whenever that condition is satisfied, that time the modulation index formula is AM by AC. Okay. Regarding AC value, same answer you will get. When you are using like whatever equation 1, here you got 2 equations, right? Regarding Vmax and Vmin. Just perform the addition, AM will get cancelled. Right hand side you are getting 2AC. That 2 if you bring left hand side, once again you are getting average of these two is nothing but AC. Okay. So whatever earlier equation you got regarding AC, same equation here also. Okay. But in general, the modulation index formula is this one. This is the special case. This is the special case. Okay. So you are getting this derived formula whenever this assumption is true. Whenever this assumption is given, like AC into Ka equal to 1, that time we can use the modulation index as AM by AC. AM by AC. Okay, I hope it is clear. Now we are going to use that one. Okay, we are going to use that formula now. Here we got mu, we got AC. Now we are going to calculate AM. Okay, so as of now we got one more formula for modulation index as AM by AC. Now I am using that formula, modulation index mu equal to AM by AC. So here modulation index is 1 by 3. AM we have to calculate. AC value we got 7.5. 7.5. So here 3, 2.5 times. 2.5 times. So from here we can write AM equal to 2.5 volts. AM equal to 2.5 volts. Okay. So in this way, suppose in some question they can ask to calculate the modulation index or to calculate the carrier amplitude or to calculate the message signal amplitude, etc. So if you remember the standard formulas, directly you can substitute, and from here you are going to get directly the modulation index, AC and AM. Okay. Here for understanding purpose, I have discussed the complete derivation, and whatever the values given we have substituted in the formulas, and from there we are getting the other parameters. Okay. But regarding AC and regarding AM, okay, without using any formula also, you can just by observing the waveform, we can easily tell. See, now I am going to show the magic. Okay, some of you might be wondering that, sir, you have done lot of derivation to find, okay, to find the values of AC and AM. Okay, see, that derivation and all we have explained just in order to get familiarity about the concept. Once if concept is clear, then you can remember the formulas easy, right? Okay, now I am giving the easiest method without remembering the formula, how to calculate AC and AM. So how many of you are eagerly waiting? All of you please respond. Without doing this much calculation and without using pen and paper, how to find AC and AM values, all of you quickly mention in the chart. I am eagerly want to see how many of you are wanted that other method. Without using pen and paper, just by observing the waveform, we can tell directly AM and AC for the given waveform. All of you quickly mention. Yes, most of you, right? Yeah, very good. So here if you observe, here, see, this is the message signal, okay. This message signal, here if you carefully observe, regarding this particular message signal, if you observe, it is varying between 5 and 10. So that means from here, you are going to get 10 minus 5 is 5 volt. 10 minus 5 is 5 volt. Okay. So that means regarding this particular signal, the peak to peak amplitude is 5 volt. Peak to peak amplitude is 5 volt. Now if you are taking half of that one, that is nothing but your AM. AM is nothing but 5 volt divided by 2, which is nothing but 2.5. See, the AM is nothing but the peak amplitude of the message signal, right? So once if you got this one, so that means here the center point, okay, center point is the reference point. Like suppose if this carrier signal is not there, what are the message signal here you're having? In general, you'll be having like this. Sorry. Okay, you are having like this. So here you are going to get the reference line. So in general, you will be having 0 volt this one. If you are considering 2.5, so this peak value is 2.5 volt, and this negative peak is minus 2.5. In general, if there is no carrier signal is superimposed, then your original message signal you are having like this. Now you can observe, regarding the message signal, the peak amplitude you are having 2.5 volt. Now, because of AC signal, because of carrier signal amplitude, what happened? Now this 2.5, you can observe at this instant, or you can observe at this instant, or you can observe at this instant. With the help of any of these three instants, you can easily find out the carrier signal amplitude. Now, for the timing I am considering, where you are getting message signal peak value, that is 2.5. Okay, here you are getting 2.5. Now, because of the carrier signal, here you are getting 10 volts. So that means this 2.5 volt is got shifted to 10 volt, right? So that means here AC is nothing but 10 minus 2.5. That is nothing but 7.5. Okay, in this way we can easily calculate without using any formula, just by observing the waveform. First of all, you are coming to know regarding the modulating signal peak to peak amplitude. Make half of that. From there you are getting the peak amplitude of the message signal. Once if you are getting that one, with the help of that, regarding overall modulated signal peak value, when you observe from this value how much it got shifted. Okay, so 2.5 plus 7.5 is nothing but 10. So that means 7.5 volt is nothing but carrier signal amplitude. I hope it is clear. Whatever we got earlier, same values. Regarding AC 7.5, regarding AM 2.5. So in this way, without using pen and paper, you can get the values regarding the message signal amplitude and carrier signal amplitude from the given AM wave. Okay, right. Now, whatever we have done, that is for the given waveform, we calculate the modulation index, we got the AM value, we got the AC value. Okay, right. Now, our requirement, if you observe the question regarding case 1 or case 2, our requirement is we have to get the modulation index as 0.1. Right. So, here I am mentioning case 2. Okay. Here we require modulation index as 0.1. So for the timing I am representing as mu dash. Okay, mu dash. So this 0.1 we can write as 1 by 10. Now here if you observe, regarding the message signal amplitude, the peak amplitude, AM is constant, peak amplitude is constant, or the amplitude of the message signal is varying between minus 2.5 to plus 2.5. Now in this particular case, since we have considered the peak amplitude of the carrier is 7.5, because of that we are getting modulation index as 1 by 3. Now our requirement is 0.1 regarding modulation index. So in order to get that one, how much AC we have to consider? That is the question, right? So that means AM value will remain same. Because here we are varying modulation index because of the carrier signal amplitude, right? So here mu dash, whatever the formula here just now we got, like AM by AC, the same formula I am going to use. But here AM remains same, but AC value we are going to change, right? Because of variation in AC, according to the modulation index is going to vary. Okay, right. So here modulation index is 1 by 10, which is nothing but AM value just now we got 2.5, and from here AC dash value we can calculate how much. Just do the cross multiplication. 10 into 2.5, that is nothing but 25 volts. Now tell me, this answer is for according to the given question. Here we are solving the question. Here you are having two subparts, subpart 1, subpart 2, right? So what is the answer we got just now? That 25 volt. 25 volt we got. So this 25 volt will be the correct answer for which subpart? Whether for first case, first subpart or second subpart? All of you mentioned? Yeah, just read the second one. For what value of carrier amplitude in volts we will get the modulation index as 0.1? Yes, for this second one, the correct answer is 25 volt. Okay, right. So this is the answer for second subpart. Okay, answer for second part of the question. Okay, right. Now just read the first part of the question. First part of the question. In order to get the modulation index as 0.1, how much value we need to add to the earlier carrier amplitude, right? So to the earlier carrier amplitude, how much we have to add so that we'll get the modulation index as 0.1. See, the question is very beautiful, right? Based on the sentence framing, okay, based on the, according to the context, you have to mention the answer accordingly, right? So here, if you observe, according to given waveform, you got AC value 7.5. Now, from you're already having AC value 7.5, for this value, how much if you're adding, so that you are going to get 25. So that will be the answer for case 1. So for answer for case 1, so here if you observe, AC dash is 25 volts, AC dash minus AC. AC dash is 25 minus. In the earlier case we got 7.5. So if you subtract both, you will get 17.5. 17.5 plus 0.5, 18. 18 plus 7 is 25. So 17.5 volts is the correct answer. So for the previous carrier signal or for the previous carrier amplitude, you are having 7.5. For that 7.5, if you are adding 17.5 volts, then we are going to get modulation index as 0.1. That is the first part of the question. Second part of the question, directly for what value of carrier amplitude, we are going to get the modulation index as 0.1. So all of you please mention how many of you liked this question, how many of you felt this is a very interesting question. This is a very, very interesting question, right? So in the GATE exam, whenever you are solving any question, after solving the question, before you are attempting, like whatever the option you feel or whatever the answer you are mentioning for any type of question, so just read once again the question. According to the context, you have to mention the answer, right? The sentence framing is very important. Whenever you're having main keywords, focus those main keywords. Accordingly, the answer may vary, right? With respect to first part of the question, answer is 17.5. With respect to second part of the question, answer is 25. Okay, right. Yes, I hope all of you liked this question. I hope all of you felt this is a very interesting question, right? So now I am going to announce at our IMS GATE Academy, we are going to provide the live online program for GATE 2025 and 2026. Whoever targeting the GATE exam for 2025 and 2026, we are providing live online program. So all of you, if you are targeting for GATE 25 or 26, okay, you can just book the free counseling session regarding this particular link already provided in the description, right? Whoever your friends or juniors, whoever targeting for GATE 25-26 program, so you can share whatever the information now I'm going to mention now. So kindly share this valuable information with all of your friends and juniors so that they also will get benefited by enrolling for GATE 25-26 live online program at our IMS GATE Academy. So at our IMS GATE Academy, whoever enrolling for live online program, we are going to provide 800 plus hours of live online classes with interactive sessions, right? So here all our faculties will discuss each and every concept from the basic level and then to application level. And here in our live classes, in order to get clarity, okay, all the students, in order to get good command over the concept, okay, in order to get the clarity over the concepts, we will discuss the practice questions and gate questions as well. And the level of the questions will start from easy, then medium, and then tough, okay. So that all the students who are attending our live classes, they will get good command over the subjects. And in addition to that, we are providing for every subject, we are providing theory book, exercise book, right? So in this exercise book, we are going to provide 3 levels of questions like level 1, level 2, level 3. So for every chapter, you will be having 60 questions will be there. And if any chapter is like very less weightage with respect to gate exam point of view, in that case, you'll be having 30 questions. Otherwise, most of the chapters, you'll be having 60 questions, right? So if you are solving all those questions, you are getting good command over the concepts and you are getting good command over how to solve any question. And in addition to that, we are going to provide 30 plus years gate question bank. The beauty of our gate question bank is we are providing wherever possible according to the given question, we are providing the alternate solution and we are mentioning the key points, okay. So if you are solving the gate questions from our gate question bank, you are getting lot of great feel you are getting, and you are getting lot of knowledge regarding how to solve the gate questions, okay. You are getting good command over the concepts and as per your branch. So definitely this is going to help a lot for your coming gate exam, whoever targeting for 25 and 26, right? So in addition to that, we are providing more than 130 online tests. So here we are going to provide for every subject at chapter level, we are providing 1 test. And then for every subject, we are providing basic test, advanced test, and multi-subject test. Okay, after that, we are going to provide all India mock tests. So in this way, if you are attempting all these tests in a sequence, then whatever you have got the knowledge from our classes, and whatever the practice you have done from our exercise book and gate question bank, and with that, whatever the knowledge you have got, whether you are confident about that particular subject or not, or how many marks you are able to score if you are in your coming gate exam, etc., you can get that habituation, you can get familiarity. Okay, for that we are providing various tests. So by attempting all these tests, definitely you are going to get good confidence, okay, before you are going to attempt the gate 25 or 2026, okay. And here in our IMS Gate Academy, we are providing my plan sessions for all our enrolled students, okay. So every student, they can book 1 my plan session on monthly basis. They can get the proper guidance and study plan from our mentors, okay. So all of you kindly share this valuable information with your friends and juniors, whoever targeting for 2025 and 26. And regarding the free counseling session, the link is provided in the description of this particular video. Okay, so you can click on this particular link or directly you can call to these numbers. Okay, right. So this is our Telegram channel, our IMS Gate Academy Telegram channel. So all of you kindly join. This is the free for everyone. So if you join, what are the benefits that you are going to get? Say for example, currently we are taking gate score booster sessions at our YouTube channel. This is free session for everyone, right? So like this, whenever upcoming sessions are there, so you will get the notification or update in this particular Telegram channel so that you can attend the live lectures, okay. And after completion of each and every lecture, whatever faculties are writing on the digital board, this particular notes we are going to share in this Telegram group in the PDF form, okay. The lecture PDF we are going to share in this particular Telegram group, right? And in addition to that, you are going to get the important updates whenever we are going to conduct seminar or webinar. And similarly, regarding the job notifications, PSUs, government jobs notifications also, you will get updated in this particular group. And similarly, not the least, on daily basis, we are providing 1 quiz question so that on daily basis, you are getting 1 opportunity to learn something new, right? And you can attempt whatever the answer you feel correct, you can mention, or you can attempt the quiz question, and very next day our faculties will provide the solution for that quiz. So you can go through the solution. In that way, you are getting, better. On daily basis, you are learning something new, right? So all of you kindly join our Telegram group. So regarding this particular link also, it is provided in the description. Okay. So now let us proceed further questions. Right. So this is a very interesting question. All of you give a try. This is a very interesting question. So this is the MSQ question. Whenever I mention choose the correct option or options, that means it is MSQ. Okay. So either one option or more than one option can be correct. So in this question, I have given one AM signal. Now regarding this particular AM signal, if you observe two choices you are having regarding the modulation index. Okay. And one choice you are having regarding bandwidth, one choice you are having total sideband power. So all of you give a try. Yeah, time up. Whatever the answers, okay, by this time, whatever the option you feel correct, you can mention, okay, and you mention the options and you can mention like correct, okay, or whichever options you by this time you could have eliminated, or which are wrong you feel, okay, you can mention the options and you can mention these are the wrong options, okay. Right, so this is a very interesting question. In this particular question, you're having the AM signal, okay. So previously we have mentioned regarding whenever you're having AM signal, regarding that the standard time domain equation we have discussed like this, AC into 1 plus K M of t into cos 2 pi of ct. After that, when you are substituting regarding M of t, either AM cos 2 pi fm into t or AM sin 2 pi fm into t, like that, then K into AM is nothing but modulation index. Okay, So if you are having only one message signal frequency, that means it is a single tone modulation. But like that, if you are having more than one message signal frequency, that is called multi-tone modulation, right? So similar equation you are going to get regarding this particular term. Similar term you are going to get, like here mu1 cos 2 pi fm1t plus mu2 cos 2 pi fm2t, like that. So whatever the given equation is there, I have copied here. This is the given AM equation. Now let us represent into the standard form. So here S of t, here you can take 10 as common. Then here you will get 1 plus 4 by 10 we can write as 0.4. Then cos, this one I am writing into the standard form, like 2 pi f format. So 2 pi into 4 into 10 power 3t. 2 pi into 4 into 10 power 3t plus 3 by 10, which we can write as 0.3 into cos 2 pi into 10 power 40. 10 power 40, if you want, you can write 10 into 10 power 3. 10 into 10 power 3 t. Okay. And this overall term we have to multiply with carrier signal or cos signal. Cos into 2 pi into 10 power 60. Now you can compare this equation with the standard equation, right? So our standard equation is S of t equal to AC into 1 plus, since you are having two frequencies regarding message signal, accordingly I am writing the representation. 1 plus mu1 cos 2 pi fm1 into t plus mu2 cos 2 pi fm2 into t. The overall term we have to multiply with cos 2 pi fct. So AC into cos 2 pi fct is nothing but carrier signal, right? So whenever you are having AM signal, AC we have to take common, or AC into cos 2 pi fct we have to take common. Then whatever the equation you are going to get, that is the standard AM signal. If you are having single tone, this part won't be there. Okay, whenever multi-tone is there, accordingly, here in this case 2 frequencies, so that means 2 terms. If you are having 3 frequencies, 3 terms like this you will get. Okay, right. Now you can compare both the equations. From here you can write AC equal to 10 volts, and mu1 equal to 0.4, and similarly mu2 equal to 0.3, and FM1 is nothing but the frequency of message signal with respect to one frequency. FM2 is the second frequency. Okay, so here FM1 is equal to 4 into 10 power 3, so that we can write as 4 kilohertz. Similarly, 10 into 10 power 3 we can write as 10 kilohertz. Similarly, FC is nothing but 10 power 6 H. So that we can write as 1 mega. So just by comparing these two equations, I have written AC, mu1, mu2, FM1, FM2, and then FC. Now whatever the choices here you're having, now let us find out one by one. Okay, option A, option B, regarding the resultant modulation index, mu t. Okay, I hope all of you know the formula. Whenever multiple modulation indices are there, like mu1, mu2, how to find the resultant modulation index. So I hope all of you know this formula. Mu t square is equal to mu1 square plus mu2 square. Like that, if you are having more than one, so accordingly how many terms or how many modulation indices you are having, like that you can continue this series. Okay, so from here you can calculate mu t as, just if you perform square root on both sides, you will get square root of mu1 square plus mu2 square. Now you can substitute mu1, mu2 values here. Mu1 value is 0.4, mu2 value is 0.3. So 0.4 whole square plus 0.3 whole square. 0.4 whole square is nothing but 0.16. 0.3 whole square is nothing but 0.09. How much you are going to get? All of you please respond. 0.16 plus 0.09, so that is nothing but 0.25. So square root of 0.25 is nothing but 0.5. So the modulation index, resultant modulation index is 0.5. Okay. So here the most interesting thing is we have to take this 10 as common. Okay. Sometime the students will be in hurry mode. Okay. They will assume that in the question only they have given 10 outside. Okay. If they have considered like that, then just by comparing this equation with this particular equation, so some students will consider this is mu1 equal to 4 and mu2 equal to 3. So 4 square is 16, 16 plus 9 is 25, so square root of 25 is 5. That's why here if you observe, intentionally I have mentioned that because of silly mistake, whatever the possible answer is there, that intentionally I have mentioned in the first choice. Generally in the GATE exam also, because of silly mistake, in general students, whatever the option they may choose, okay, whatever the answer they may choose, that answer they will intentionally keep in the option A. Because you people will be in hurry mode, okay, you don't, in hurry mode, there are more chances to do the errors, right? So that's why in the exam, you will feel that your answer is happy, but after seeing the answer key, you will be like disappointed, right? So that's why always, even though if you are very good at concept, during the exam, you should be as much patience, you should have more patience, okay? Don't be in hurry mode, even though if you are good at concept, but try to solve that question in the less time, whereas the calculation part is there. But before attempting the question, okay, you just read the question once again, whether whatever the equation they have given, whether it is in the standard form or not. If it is in standard form, then directly your answer will be correct. But if it is not in the standard form, try to arrange in the standard form. So after that, what is the answer you are getting, that will be correct. Okay, right. So this is the learning for everyone. So option A is not correct. Only option B is correct. Among option A and option B, only option B is correct. Okay. Now let us verify regarding C and D whether those options are really correct or not. So regarding option C, you are having bandwidth. So as of now, we got option B is correct. Now regarding bandwidth of AM signal. So whenever you are having multi-tone signal, the bandwidth is 2 times the maximum frequency of whatever the signal frequencies we are having regarding message signal or modulating signal, right? So here if you observe, we got 2 frequencies regarding the message signal. One is 4 kilo and another one is 10 kilo. So just by observing these two, the maximum frequency that we are going to get 10 kilohertz. Now we have to consider this particular signal frequency. 2 into 10 kilohertz. Into 10, that is nothing but 20 kilohertz. Yes, option C is correct. 20 kilohertz is correct. Bandwidth of AM signal is 20 kilohertz. It's correct. Now we have to calculate the total sideband power. So first of all, I am writing the total power of AM signal. That is PC into 1 plus mu square by 2. For generalized case, mu t square by 2. So from here, multiply PC with both, you are getting PC plus TC mu t square by 2. So this is your carrier power, this is your total sideband power. Now in the question they are asking total sideband power, so this particular term we have to consider. So the total sideband power equal to PC mu t square by 2, where PC is nothing but AC square by 2. PC is nothing but AC square by 2 into mu t square divided by 2. So from here you are going to get AC square mu t square divided by 2 into 2. See, both are in the denominator. Sometimes students will in hurry mode, they will cancel these two. Okay, but both are in the denominator only, right? Whenever both are in the denominator, you have to multiply. 2 into 2, you are getting 4. So now you can substitute AC value. AC value, we are having 10 volt. AC value 10 whole square. Mu t square. Mu t value we got 0.5. Square of 0.5 is nothing but 0.25. 0.25 divided by 4. Divided by 4. So here 100 into 0.25 is nothing but 25 divided by 4. Yes, AC square is nothing but 10 square and mu t square. Mu t square value is, mu t value we got 0.5, 0.5 whole square is 0.25, right? 0.25 into 100 is nothing but 25 divided by 4. Okay, so 25 divided by 4, you will get 4 6 are 24, here 10, 4 2s are 8, 25. Okay, so 6.25 you are getting, 6.25 you are getting. But here in option D, we have mentioned as 12.5. So 12.5, is it correct? No. So this is not correct. Total sideband power is 12.5, that is not correct. Okay. So here we are getting, see, while you are doing the calculation, you have to represent carefully. Here PC is nothing but AC square by 2 and here mu t square and denominator 2. 2 into 2 is nothing but 4. So because of this, here you are getting 6.25. Suppose if you have got only 1 2 in the denominator, then 25 by 2 suppose. Then in that case, 12.5 will be correct. 12.5 you can get correct. But here 12.5 is not the correct. Okay. So as of now, among 4 choices, only 2 choices are correct. Option B and option C. I hope it is clear. Okay, now let us see the next question. This question is based on DSBSc demodulation. This question is based on regarding DSBSc demodulation and regarding the synchronous detector. So all of you just read the question carefully. Here in this question, regarding the carrier signal that they have used at the modulator and at demodulator, there is some phase angle difference is there. Okay. So in this question that they have mentioned the phase angle difference, that is 45 degrees. So because of this one, at the output of synchronous detector, what expression you are going to get? Okay. Here M of t is nothing but message signal. So all of you give it a try. All of you give it a try. This is a simple question, direct question based on synchronous detector, which we are using for demodulating the DS-based signal. Right. Yeah, time up. Whoever got the answer, okay, you can mention the chart. So first let us read the question. Here, DS-based modulation is used in the communication system having sinusoidal signal as the message signal. Okay, for the timing here in all the options they have mentioned it is M of t. That M of t is nothing but message signal. Here they have considered it is the sinusoidal signal. Okay, right. And regarding the carrier signal, it is mentioned like 4 cos omega ct. It is like AC cos 2 pi f ct, where omega is nothing but 2 pi f. If there is a phase shift of 45 degrees between the carrier signals which are used in the modulator and synchronous detector, then we will get the output of synchronous detector as. Okay, so I hope all of you know the block diagram of synchronous detector. So what are the main, in the block diagram of synchronous detector, what are the 2 main blocks we are having? Obviously it is a simple block diagram which consists of 2 blocks. Can you recall what are the 2 blocks that we will be having in the block diagram of synchronous detector? All of you quickly respond. Quickly mention the chart. Here we are going to have 2 blocks regarding synchronous detector. Can you recall? Yes, very good. The first one is multiplier. Multiplier or product modulator. And the second one is low pass filter. So here we are going to multiply 2 signals. Obviously whenever you are using decoder or demodulator, obviously the input should be the modulated signal. In this case it is a DS-based signal. So here DS-based signal is the input. Okay, and here the carrier signal. Okay, so here the carrier signal, generalized case I am representing like this, AC cos 2 pi f ct. But in the question it is mentioned that there is a phase shift between the carrier signal that they have used at the transmitter and that which we are using at the receiver or in the demodulated circuit. Okay, so for the timing I am assuming that here there is a phase shift of phi. See, you can observe here in the modulator they have used the carrier signal as 4 cos 2 pi f ct. So that means there is no phase angle difference here, right? So if you are considering generalized format like AC cos 2 pi f ct, so with respect to that, here I have considered AC cos 2 pi f ct plus phi. Okay, right. So regarding DS-based signal, which is nothing but M of t into C of t. Okay, so for the timing I am representing DS-based signal as S of t. Now let us write the output expression at the output of multiplier. Okay, so output of multiplier which is nothing but S of t into AC cos 2 pi f ct plus phi. AC cos 2 pi f ct plus phi. Okay. Now regarding S of t, I hope all of you are very much familiar regarding double sideband suppressed carrier. What is the equation or expression for regarding DS-based signal in time domain? All of you quickly respond. Yes, it is the just product of the message signal and carrier signal. That's all. It is just product of message signal and carrier signal. So regarding message signal, we are considering M of t. Regarding carrier signal, we are considering AC cos 2 pi f ct. AC cos 2 pi f ct. So this is your DS-based signal. Okay. Now we are considering AC into cos 2 pi f ct plus phi. Okay, right. Now M of t you can keep as it is. AC into AC, that is nothing but AC square. AC square. Now, for the timing I am writing this term here. Cos 2 pi FCT plus phi. And then I am writing this term here. Cos 2 pi FCT. Now if you observe this expression, it is in which form? Cos A, cos B you are getting. But we know the standard trigonometric equations like 2 cos A, cos B. Right? So in order to get that standard equation, so here I am multiplying with 2 and divide with 2. So 2 will get cancelled. We are getting 2 cos A, cos B format. I hope all of you know the formula regarding 2 cos A, cos B. What is the formula? 2 cos A, cos B is nothing but cos sum plus cos difference. Two cos A cos B is nothing but cos sum plus cos difference, right? So now you can use that formula. From here we are going to get output of multiplier equal to m of t AC square by 2. You can write as it is 2 cos A cos B is nothing but cos sum plus cos difference. Cos sum means you have to add these two. You have to add these two. 2 pi FCT plus 2 pi FCT. That means 4 pi FCT plus phi. Cos 4 pi FCT plus phi plus cos difference. When you have performed the difference of these two, A minus B, 2 pi FCT will get cancelled. You are getting simply phi. Cos phi. Now multiply this term with these two. So m of t AC square by 2 into cos 4 pi FCT plus phi plus. Once again multiply this term with second. M of t AC square by 2 into cos phi. M of t AC square into cos phi divided by 2. Now just observe these two terms. Just observe these two terms. These two terms you are going to get at the output of multiplier. Now whatever the two terms here you are getting, these two terms we are passing through low pass filter. Now can you tell among these two terms which term will be allowed by the low pass filter? Among these two terms which term will be passed by the low pass filter? As the name implies, low pass filter pass only the low frequency component, and regarding the low pass filter, you can consider the cutoff frequency as message signal frequency, FM. Okay. So here if you observe, AC square is the constant, cos phi is the constant, 2 is also constant. So this overall factor, whatever you are getting, that is a scaling factor. Here only the time varying component m of t is there. So regarding this, you are having the frequency as FM. So obviously this particular term is passed by the low pass filter. What about here? Here you are getting 2 pi FC format. So when you are writing 2 pi FC format, so from here you are going to get the frequency as 2FC. Regarding this particular term, the frequency is 2FC. But here AC square by 2 is the constant. But regarding m of t, the frequency is FM. Just like here, regarding m of t, the frequency is FM. Now we are multiplying two time domain signals, which is one of the signal is having the frequency FM, whereas the other signal is having the frequency 2FC, right? So when you multiply these two signals, the resultant frequencies that you are going to get, here in this case, the frequency you got 2FC, 2FC plus FM, 2FC minus FM, right? 2FC, so generalized case I am representing plus or minus FM. See, in general, if you are having like m of t and c of t, so regarding c of t, you will be having fc. So fc plus fm, fc minus fm. So in the similar way, in place of fc, you are having 2fc. Because of that, you are getting 2fc plus or minus fm. So obviously, fc itself is very high when compared to fm. Obviously, 2fc component is far greater when compared to fm, right? So obviously, this particular term is not allowed by the low pass filter. So ultimately at the output of low pass filter, we are going to get only the second term. Okay, the first term is not allowed by the low pass filter because it is having high frequency components, right? So now I am writing output of low pass filter. output of low pass filter, so which is nothing but m of t into AC square cos phi divided by 2. Now you can substitute regarding AC, regarding cos phi value you can substitute, and from there you are getting one expression in terms of m of t. Okay. So m of t I am keeping as it is. Now according to the given question, AC is nothing but 4. AC is nothing but 4. So that means here 4 square into cos. Phase angle difference between the carrier signals in the question, it is mentioned as 45 degrees. 45 degrees. So cos 45 degrees divided by 2. Right. So m of t as it is, 4 square is nothing but 16 into cos 45. Cos 45 is nothing but 1 by root 2. Cos 45 is nothing but 1 by root 2. Here in the denominator you are having 2. So 2 8s are 16. So m of t into 8 by root 2 you are getting. So you can multiply and divide with root 2. Multiply and divide with root 2. Root 2 into root 2 is nothing but 2. Right. So here 2 4 times. 2 4 times. Okay. So that means you are getting m of t into 4 root 2. M of t into 4 root 2. So this is the output you are getting. See, in the synchronous detector you are having 2 blocks. Okay. The first block is multiplier and the second block is low pass filter. So at the output of low pass filter, whatever you are getting, that is nothing but at the output of synchronous detector. Right. So here we are getting m of t into 4 root 2. Now let us observe the options. Yes, option C is matching. 4 root 2 into m of t. Okay. So in this way, whenever you are getting the questions regarding the modulation or demodulation, okay, what are the block diagrams you have studied? Okay. So just remember the concept. Okay. Whatever the basic blocks we are having, just recall. Okay. See, regarding derivation and all, you can do, because ultimately here we are using the trigonometric equation, right? 2 cos A cos B or 2 sin A cos B, etc. or 2 sin A sin B, etc. Okay. So definitely you can answer these questions simple. Okay, in easy time only, in less time only. But only the difference, if you are not able to recall the concept, then definitely, even though it is a simple question, you people may not answer these kind of questions in the GATE exam. Okay, so just because in the communication system subject you are having lot of concepts and lot of equations also. Okay, so no need to remember all the equations, but wherever required, try to remember the special equations. But whereas remaining equations and all, if you are able to remember, you can. But otherwise, it's not necessary that you have to by heart all the equations. Not required. Just focus on the concept. Whatever the formulas required, you can derive in a couple of minutes. Okay, right. Yeah, this is the next question. So this is also interesting question. It is the MSQ. It is the MSQ. You can observe here. Choose the correct option or options. Whenever I am mentioning like this, obviously it is the MSQ question. Either one option or more than one option can be correct. So in this question, if you observe, for the modulation index of 0.3, so you have to consider modulation index as 0.3, and for that value, okay, when compared with the amplitude modulation, if you observe two choices regarding DSBSC and two choices regarding SSBSC in terms of percentage of power saved. Okay, when compared to AM, the percentage of power saved in DSBSC, in option A it is mentioned 95.69, in option B it is mentioned 92.5. Whereas, when compared to amplitude modulation, in option C and option D, the percentage of power saved in SSBSC will be 98.95 or 97.85. Right? So just by looking at the choices, since it is a MSQ, okay, among option A and option B, at max one option can be correct. Similarly, among option C and option D, at max one option can be correct. So just recall the basic formulas regarding percentage of power saved, okay, and substitute the modulation index as 0.3, and from there you can get the whatever the values you are getting, just compare with the given choices which option it is matching. Okay, either single option or two options. At max, for this question, at max two options can be correct. All of you give it a try. Yeah, time up. So here, first let us solve the question with respect to DSBSC, after that with respect to SSBSC. Okay, right. So in general, first let us consider whenever you are having AM signal, the power that required for transmitting AM signal is PT equal to PC into 1 plus mu square by 2. 1 plus mu square by 2. Okay, so just represent this one into two parts, like PC plus PC into mu square by 2. PC plus PC mu square by 2. So this is the carrier power and this is the total sideband power. Okay, right. This is the total sideband power. Now, in the DSBSC, as the name implies, double sideband suppressed carrier. That means we are completely suppressing the carrier. That means we are not giving any power to the carrier signal, right? So that means the carrier power, whatever the power that is required for giving to the carrier, that much power we are saving in the DSBSC when compared to AM signal, right? So in the DSBSC signal, here we have to calculate the percentage of power saved. Okay, so here power saved is equal to. Okay, here we are giving the total power to both the sidebands. That means this much power we have saved. So the carrier power will come into the numerator, and now we have to compare with AM signal. That means regarding AM signal, this much power required. So this expression you can consider PC into 1 plus mu square by 2. 1 plus mu square by 2. Okay, so here PC will get cancelled. So just do the simplification. Here you will get 2 divided by 2 plus mu square. 2 divided by 2 plus mu square. So in place of mu, you can substitute modulation index as 0.3. So 0.3 whole square is nothing but 0.09. So 2 divided by 2 plus 0.09. Okay, so that means you are getting 2 divided by 2.09. 2 divided by 2.09. So from here you will get 95.69. Okay, here I mentioned in terms of percentage. Okay, you will get like 0.9569 because they have asked, whenever efficiency means always they will ask in terms of percentage. Whatever the value you got, you represent, multiply and divide with 100. So 0.9569, when you are multiplying with 100, you will get like this. In the denominator 100, we are representing like percent, right? Percent. Cent is nothing but 100, right? So 95.69. So just observe 95.69 we are having in option A. So that means straight away you can eliminate option B because both are related to DSBSC. I hope it is clear. Now let us find out regarding SSBSC. So here the full form of SSBSC is single sideband suppressed carrier, right? So in this particular modulation technique, we are passing only one of the sideband. That means when compared to AM, we have saved the carrier power, we have saved one of the sideband power, right? So that means here the efficiency, the power saved. Here the power saved. Whenever the questions related to efficiency or power saved, they will ask in terms of percentage. Okay. So here the question is regarding power saved. Power saved in SSBSC when compared to AM signal, right? When compared to AM signal. Now denominator term as usual, that is PC into 1 plus mu square by 2. Now can you tell what is the numerator term? Here carrier power we are suppressing. That means that much power we are saving in SSBSC. So obviously it will come. Now in addition to that, this is the total sideband power, out of which we are passing or we are giving power only to one of the sideband. That means to other sideband, whatever the power here you are giving, that much amount of power we are saving, right? So whatever the total sideband power here you are having, PC mu square by 2, just consider half of that. That is nothing but single sideband power. You are having upper sideband and lower sideband. So any one of the sideband power you can consider. Suppose if you are transmitting upper sideband, lower sideband power you have saved. Or if you are transmitting lower sideband, you have saved upper sideband power, like that. Okay. So PC mu square by 2 divided by 2, which is nothing but PC mu square by 4. PC mu square by 4. I hope all of you are getting the clarity. Okay. Now in the numerator you can take PC as common. After that PC will get cancelled. So here you will get 1 plus mu square by 4. Here you will get 1 plus mu square by 2. PC if you take common, numerator denominator you are having PC, it will get cancelled. Okay. Now if you want you can do further simplification. 4 plus mu square divided by 2 plus mu square into this denominator. You are having 4 here. This 2 will go into the numerator. So that means here in the denominator you are getting 2. So 4 plus mu square. Mu square is 0.3 whole square divided by 2 plus 0.3 whole square into 2. So just do the simplification. Tell me what is the answer you are getting. Try to mention the answer in terms of percentage. Yes, I hope all of you are getting 97.85. 97.85 percentage. Okay. 97.85 percentage. So that is there in option D. So obviously option C we can eliminate. So for this question, two choices are correct, option A and option D. So in this way, whenever you are getting MSQ questions, so regarding communication system subject, for solving any question, if you are having like more than one parameter, so in one choice they can ask one parameter, right? So in that case, either one option can be correct or more than one option can be correct. Okay, in few questions like this, okay, they are asking just by observing the choices you are getting the clue. Okay, two choices are related to one parameter, two choices are related to one parameter. Okay, here ultimately parameter is percentage of power saved, but here the context is with respect to DS/C, here the context is with respect to SS/C. So in this way you are getting the clue. Among these two choices, at max one option can be correct. Among these two choices, at max one option can be correct. Okay. So the final answers, correct answers for this question is two options, A and D. A and D. Yeah, this is the next question. This is a question based on frequency division multiplexing. And this is a conventional question. As of now, this question I kept in the conventional way. Okay, instead of MCQ or NAT or MSQ, instead of that, I have kept this question as conventional. So here actually you are having three signals, message signals. Okay, for the first signal, the maximum frequency is 5 kHz. For the second signal, maximum frequency is 10 kHz. Whereas the third signal, maximum frequency is once again 10 kHz. Those three signals we want to transmit, okay, through a channel with the help of frequency division multiplexing. Okay, whenever you are transmitting more than one signal, in order to separate two signals, we will provide some guard band. In this question, it is mentioned 2 kHz. Okay, in some question, they will specify that there is no guard band allowed. So that means no need to separate one signal with another signal. But whenever they mention guard band is provided, so say for example, first and second, in order to separate, we can consider this guard band. Similarly, second and third, you can consider this guard band like that. Now, determine the bandwidth of the multiplex signal in following cases. Okay, here we are solving this question in four cases. This is the conventional question. Okay. So, since you are having three signals, whenever you are transmitting any signal through a channel, before sending the signal directly like that, we will obviously perform the modulation operation. Okay. So, in case 1, it is mentioned that for every signal, we have used AM modulator. Okay. With the help of that, what is the resultant bandwidth that we require? That you have to find out. Similarly, with respect to case 2, all the modulators we have used DS/C. And third case, all the modulators we have used SS/C. And see the last question, that is the more interesting. For the first signal, we have used AM modulator. For the second signal, we have used DS/C modulator. And for the third signal, we have used SSBSC modulator. In that case, how much bandwidth we are going to get. Okay, when you are transmitting these three signals through the channel with the help of frequency division multiplexing. All of you give it a try. I will give 2 minutes time. Yeah, time up. What are the answers? See, here I have given 4 cases. Okay, some of you might be still solving this question. No problem. For whichever case you might have tried, you can mention the answer and you can mention the case number. Okay, here we are solving the question in 4 cases, right? Okay. So, here in this question, you are having 3 signals. Regarding the message signals, you are having 3 message signals. So, with respect to first message signal, the frequency is 5 kHz, second and third you are having 10 kHz. Okay. Okay. So these are the maximum frequency with respect to first signal, second signal and third signal. Right. Now here we have to transmit these 3 signals in a channel by using FDM concept. So before transmitting in the channel, we have to perform the modulation technique. Okay. So here in case 1, for the timing let us consider case 1, all the modulators used are AM modulators, right? So for the first signal, second signal, third signal, we have used AM modulator. Okay. So whenever you are using AM modulator, I hope all of you know how much bandwidth we require. How much bandwidth we require? Whenever we are using AM modulator, case 1 I am considering. So for AM modulator, whenever you are using bandwidth, how much bandwidth we require? 2 times maximum frequency of the message signal, right? 2 into FM. 2 into FM, right? So now for this particular signal we have used AM modulator, for this particular signal we have used AM modulator, for this particular signal we have used AM modulator. So the corresponding bandwidth that we require is whatever the signal frequency here we are having, we have to multiply with 2. Okay. So that means here with respect to signals, 2 into So here the bandwidth of multiplexer signal I am writing here. Bandwidth of multiplexer signal is equal to 2 times, here with respect to first signal it is 5K plus 2 into with respect to second signal 10K plus 2 into with respect to third signal once again 10K. So if you are considering only this much, that means we haven't separated, okay, we haven't separated first signal, second signal, or second and third, okay. So that means if you are calculating this value, what is the answer you are getting? That answer will be applicable if there is no guard band provided between the two signals. But in this question, it is provided regarding the guard band. The information provided regarding guard band, it is 2 kHz, right? So that means you, in order to separate first and second signal, we have to use one guard band, that is 2 kHz. Similarly, in order to separate second and third, we have to use guard band 2 kHz. Okay, after the third signal, not required. Between first and second, second and third, like that. Okay. So here 2 into 5, that is nothing but 10K plus 2 into 10K, that is nothing but 20K. Once again same 20K. Then 2 plus 2 is 4. So here 20 plus 20, 40, 40 plus 10 is 50, 50 plus 4 is 54. So we require 54 kHz bandwidth in order to transmit these three signals with the help of 3 AM modulators. And then if you are using FDM concept, then we require 54 kHz bandwidth. Okay, now case 2. Case 2, if you observe, if you are considering all the modulators are DSBSC. So for whenever you are using DSBSC modulator, what is the bandwidth of DSBSC signal? See, in the AM signal, you are having both the sidebands, and along with that, you are having carrier signal, right? So that means the maximum frequency and minimum frequency of AM signal and DSBSC signal both are same. The only difference here at the carrier frequency, you are not getting any signal component, whereas here you are getting carrier signal at carrier frequency also you are getting some signal value, right? That is the reason. Ultimately, in the DSBSC, that means double sideband is there, upper sideband and lower sideband, right? So upper cutoff frequency is FC plus FM, lower cutoff frequency, okay, that is lower sideband frequency, that is FC minus FM. So when you are taking the difference, you are getting 2 FM only, okay. So that means regarding AM and DSBSC, the bandwidth is same, 2 times maximum frequency of the message signal, right? So that means since bandwidth is same, what is the calculation here we have done? Same calculation. So that means here for case 1 and case 2, the final answer will remain same. So when you are considering AM modulator or DSBSC modulator, if you are considering all the modulators AM or all the modulators are DSBSC, the final answer remains same, because bandwidth of AM signal and bandwidth of DSBSC signal both are same, that is 2 FM. Okay, right. So 54 kHz for first case and second case. Now let us see the third case. All the modulators used are SSBSC. Now all of you please respond, what is the bandwidth when you are using SSBSC modulation? See, as the name implies, we are passing only one sideband, either upper sideband or lower sideband, right? So that means you are getting the bandwidth of SSBSC signal is nothing but the message signal frequency. So in this case, the bandwidth is nothing but FM, that's all. Okay, right. So now we can calculate bandwidth of multiplexed signal. Bandwidth of multiplexed signal. See, earlier case, since we got 2 times FM, whatever the frequencies here we are having, we have multiplied with 2 and then we have added. But whereas here, simply FM, so what are the frequencies here we are having, just you can add. So 5K plus 10K plus 10K. Now after this, just like here, in order to separate first and second, we require 2 kHz. In order to separate second and third, we require 2 kHz God band, right? So 2K plus 2K. If you are not considering this God band, that means without God band or there is no God band between any two signals. Okay, right. So here in this case, 10 plus 10 is 20 plus 5, 25, 25 plus 4, 29. 29 kilohertz. So now you can observe with the help of this simple example, you can understand that with respect to real-time application, we can use with respect to bandwidth, if you observe, with the help of, say for example, if you are having 54 kilohertz bandwidth, then with the help of AM modulators or with the help of DSP-C modulators, we can pass these three signals. But whereas here, if you are using all the modulators or SSBSC, in order to transmit these three signals, 29 kHz is sufficient. The bandwidth, 29 kHz is sufficient. So that means whatever the remaining frequencies you are having in the channel, so that remaining frequencies we can allocate for transmitting some other signals. Okay, in that way we can effectively utilize the channel if you are using SSBS signal. So with respect to practical application point of view, whichever signal with the help of whichever modulator, if you are getting the less bandwidth, that means in the channel you can transmit more number of signals. Okay, right. Now let us solve the question in case 4. Okay. In case 4, the first modulator is AM and the second modulator is DSBSC and the third modulator is SSBSC. Okay, right. So with respect to AM, the bandwidth required is 2 times FM. 2 times FM, that is nothing but 2 into 5K. So which is nothing but 10 kHz. Next. So here I am writing bandwidth of multiplexer signal directly. Bandwidth of multiplex signal. Okay. Here DSBSC also 2 times maximum frequency of the message signal. Here in this case 10 kHz, 2 into 10K, 2 into 10K. Now regarding SSBSC only FM, but the third signal maximum frequency is 10K. And if you are adding only these three, that means you are getting the answer without God band, or if there is no God band. But in the question it is mentioned God band is there. So for separating first and second 2 kHz, and similarly for separating second and third, we have to use 2 kHz God band. 2 into 5K is 10K, 2 into 10, that is 20K plus 10K plus 4K. So in this case, 10 plus 10 is 20, 20 plus 20 is 40, 40 plus 4, that is 44. So in this case, we are going to get 44 kHz bandwidth. Okay, so we have solved the question in all the 4 cases. In case 1, all the modulators are AM, and similarly case 2, all the modulators are DSBSC. Because bandwidth is same, the final answer will remain same for case 1 and case 2. Whereas in case 3, all the modulators are SSBSC. In this case, we got 29 kHz. Similarly, in the 4th case, first modulator is AM, second modulator is DSBSC, third modulator is SSBSC. So when you have considered like that, you are getting 44 kHz. I hope it is clear for everyone. Now I will show the next question. So up to now, we have solved the questions regarding first chapter. Now we are going to start the questions regarding second chapter, that is angle modulation. Okay. So in this question, here also if you observe, choose the correct option or options. So that means once again you are getting MSQ. Okay, the previous question we have solved conventional, but in this particular session, we are going to discuss the MSQ questions, MCQ questions, NIT questions, and conventional questions also, right? So from the conventional questions, you are getting the opportunity to get deeper understanding about the concept. Of course, in the GATE exam, they won't ask conventional questions. Definitely, you'll be having options, or the question will be like NIT type. Okay. So here we have provided one frequency modulated signal. Okay, FM signal you are having. So for this particular signal, if you observe option A, option B, once again, two choices are related to bandwidth of FM and two choices are related to power of FM signal. So just by looking at options only, you can at least you can identify that among option A and option B, at max one option can be correct. Similarly, among option C and D, at max one option can be correct. So all of you give a try. I will give some time. At least some of you can try for bandwidth and other students can try for power of the FM signal. After that, whatever the option you feel correct, you can mention in the chart. Yeah, time up. What are the answers you're getting? You can mention in the chart. Yeah, first let us consider the given FM signal. This is a FM signal given, right? So just compare the given FM signal with the standard equation of FM. Okay, in the previous chapter, we have focused regarding the standard equation of AM signal and DS based signal, right? Similarly, you'll be having SS based signal also. Okay, so here this question is based on FM signal. So you represent, first of all, the standard equation of FM signal, time domain equation. So regarding FM signal, the standard equation is S of t equal to AC cos 2 pi FCT, AC cos 2 pi FCT plus beta. In the AM signal, we are having the modulation index representation mu. Okay, whereas in the FM, we are representing the modulation index with the letter beta. Okay, or symbol beta. Beta sine 2 pi FM into t. Suppose if you are having cos here, accordingly we'll represent. Okay, since you are having sine, accordingly. S of t equal to AC cos 2 pi FCT plus beta sine 2 pi FM into t. Now compare this equation with the given equation. From there, write each and every parameter, and after that, whatever they have given in choices, accordingly we will find out. Okay, among the given choices which are really correct, let us identify. So for the timing, when you compare these two equations, AC is nothing but 50. So if you want, you can represent units or volts. For the timing, we are considering whatever the modulated signals we are having. For the timing, we are representing in terms of voltage. Okay. So AC equal to 50 volts. Here, cos 2 pi FC. FC is nothing but 10 power 6 H. So 10 power 6 H, we can write it as 1 megahertz. 10 power 6 is nothing but 1 mega. 10 power 3 is nothing but 1 kilo. Right? Next, beta is nothing but 3. Beta equal to 3, this is greater than 1. So whenever beta value, if you are getting greater than 1, which indicates which type of FM? Yes, very good. It is the wideband FM. Whenever modulation index value or beta value greater than 1, in FM case, we are calling it as wideband FM. That means the given mathematical equation represents wideband FM. Right? Wideband FM. Now, sine 2 pi FMT. So here you are having 2 pi FM. 2 pi FM. So which is equal to, here you are having 1000. 2 pi FM equal to 1000. So here 2, 500 times. So from here you are going to get FM equal to 500 divided by pi. 500 divided by pi. Okay, sometimes some students will be in hurry mode. Okay, here also, just like here you are having 2 pi actually. Okay, in a similar way, sometimes students will assume that the pi term is present here. Okay, so say for example here 1000 t is there, right? Instead of 1000 t, some students will assume that 1000 pi t is there. Okay, because of that, what will happen? FM equal to 500 Hz you will get. FM you will get 500 Hz. So don't make any assumptions. Don't be in hurry mode. Okay. So always, whatever the notation they have given, accordingly you can consider. Then definitely, whatever the answers you are getting, definitely those will be correct. But if you are in hurry mode, because you are assuming something, whatever the data given in the question is something else, whatever you are assuming something else, definitely whatever the answer you are getting, definitely will be wrong, right? So don't do, whenever, if you know the concept very well, at that time you should be as much patience as possible so that you can get the correct answer. Okay. Don't be in hesitate mode. Okay, don't be in hurry mode. Okay, so this is the answer. So regarding FM, we are getting 500 by pi. Here units I am representing H. Whenever you are having frequencies in the normal representation, obviously you will be having the units will be H. Okay. Now, since as of now we got one observation point is the given FM signal is wideband FM signal. Wideband FM signal. Okay, we calculated just by comparing both the equations, whatever the parameters here we are having, and we have represented each and every parameter value with the help of given equation. Okay. Now in option A and option B, it is mentioned regarding the bandwidth of FM signal. Regarding the bandwidth of FM signal. So what is the formula? when we are having wideband FM, what is the bandwidth formula? Bandwidth of wideband FM. What is the formula? 2 into beta plus 1 into FM. 2 into beta plus 1 into FM. So here beta value just now we got 3 plus 1 into FM value just now we got 500 divided by pi. 500 divided by pi. So here 3 plus 1 equal to 4. Here 3 plus 1 is 4. 2 into 500. We can write as 1000 divided by pi. So here bandwidth units you will get in the order of H. So 4000 by pi H. 4000 by pi H you are getting. Or that 1000 if you want you can represent in the order of kilo also. So this 1000 I am representing as kilo. So that means 4 by pi kilo H. 4 by pi kilo H. Now you can observe the choices. Yes, option B is satisfying. 4 by pi kilo H. Whereas in option A, 4 kilo H is there. Because as I mentioned earlier, in the given equation, here also if you are assuming pi is there, because of that, here while you are writing FM, you won't write pi here, you will write simply 500. So because of that, in the denominator you won't get pi. Okay, so simply you will get 4 kilo H, right? So if you are in hurry mode, then in this question you will choose option A, right? So earlier also one of the question I have mentioned, because of silly mistake or because if you are in hurry mode, if you are doing wrong assumptions, because of that, whatever the possible answer you may get, that option obviously it is wrong. Intentionally I am keeping in option A, so that all of you are getting with the from this particular gate score booster session, all of you are getting one opportunity or learning that how to avoid the silly mistakes, right? Especially regarding communication system subject, because the subject is very vast, right? Syllabus wise and equations wise, it is a lengthy subject, or more number of equations, and even solving questions also. Some questions you can solve in less time, and some questions definitely it will take more time, right? So while you are solving communication system subject questions, if you are having patience, definitely you can get correct answers. But if you are in hurry mode, even though you are good at concept, but there are chances to get wrong answers, right? So the moment if you are getting wrong answers, definitely if the question is MCQ, you will be getting negative marking. But if it is MSQ, of course there is no negative marking, but there is no partial marking also, right? But if you know the concept, definitely you should get marks assigned for that question. But if you are losing the marks, that means if whatever the question given, if it is out of box question, or if you don't know the concept awareness regarding that particular question, then no problem. But if you know the concept, but if you are unable and you solve the question, but because of hurry mode or because of silly mistake, if you are losing marks, that means it is a regret. Because after attempting the GATE exam, you are not getting one more chance, right? You will get one chance in every year. But say for example, if you are targeting GATE 2024, that exam will happen only one time, right? So it won't repeat. But if you are targeting for 25, 26, then you are having upcoming years, okay? Whoever targeting for the upcoming years, so this GATE 2024 is a, from the GATE 2024 exam, you are getting one experience. But whoever targeting GATE 2024 is your target year, right? Then you people should not do even single silly mistake in the GATE exam. So how you can overcome that silly mistakes? For that, you are getting the opportunity from our GATE score booster sessions, right? So here in this particular series regarding communication system subject, I am mentioning wherever possible, in general, where the students will do silly mistake, I am highlighting so that all these are learnings for all of you, so that whoever attending our sessions, at least those students won't do such kind of silly mistakes. Not only regarding this concept, even whatever the learnings you are getting from this series, definitely it will be helpful for even other subjects as well, right? I hope all of you are getting the importance of our GATE score booster sessions. So kindly share our GATE score booster sessions with your friends and juniors, whoever targeting for the GATE 2024 exam, so kindly share so they also will get benefited by watching these lectures in their free time, right? Okay. So as of now, we got option B is the correct. So option A is not at all correct. I have already mentioned. Option A will be correct provided if pi is there. 1000 pi t. If it is there, then definitely option A is correct. In that case, option B is wrong. Okay, fine. Now in option C and option D, you are having regarding power of FM signal. What is the formula for power of FM signal? So here we are having wideband FM. So what is the power? Power of FM signal, which is nothing but carrier power only, right? Power of wideband FM signal, which is nothing but carrier power only. So PC is nothing but AC square by 2. AC square by 2. So here AC is nothing but 50. So substitute here 50 whole square divided by 2. So 50 whole square is nothing but 50 into 50 divided by 2. Okay, so here 225 times, then 525 are 125. After that you are having 0. So here you are getting in the order of watts. Okay, 1250, 1250 watts. But now you look at the options. Here you are having options in the order of kilowatt. Okay, so try to represent whatever the answer you got, represent in the order of kilowatt. So what you can do here, you can represent 1.25 kilowatt. 1.25 kilowatt. See, when you are representing kilo as 1000, okay, so when you are multiplying 1000 with 1.25, you will get 1250. 1250. So that means 1.25 kilowatt is the correct answer. 1.25 kilowatt is the correct answer. So obviously option C is not correct. Option C is not correct. In this way, whenever you are having MSQ questions, just by observing the options, you can guess that among all options, okay, which options can be correct at max, which options can be correct, okay, among the given options. Okay, in that way you can just proceed. Say for example, here if you are targeting with respect to power, at least one of the at max you can choose one option here. Similarly, whoever targeting bandwidth, at max among these two choices you can choose one. Okay, suppose if the question is MCQ, say for example if you have solved with respect to bandwidth, okay, suppose luckily you got one of the two choices, then you don't need to verify regarding other two, like that. Okay, that is the difference between MCQ and MSQ. If the question is MCQ, the moment if you got the correct option, you don't need to verify the remaining options whether those are really correct or not. Okay, but if the question is MSQ, you have to verify each and every question, each and every choice, whether it is really correct or not. That means whenever you are attempting any MSQ question in the GATE exam, just look at the question. If you can solve that question in less time, definitely you can attempt at that time. But if you think that for solving that question it may require more time, then better hold that question at that time. You can try those questions at later point of time during your GATE exam. Because whenever you are having MSQ questions, at max 4 choices can be correct, right? Either one option can be correct, or 2 options can be correct, or 3 options can be correct, or at max 4 options can be correct, right? So that means you are solving the given question 4 times, right? So that's why you should play the strategy, whether you have to attempt that MSQ at that point of time or later point of time. Okay, so whichever MSQ you can solve in less time, definitely you can attempt at that time. And whichever MSQ you feel that it requires more time, definitely you can hold that question at that point of time. You can attempt at later point of time. Okay, so I hope all of you got the clarity. Now I will show the next question. This is also MSQ question. This is also MSQ. You have to choose the correct option or options. Once again, here also I have given regarding FM signal only, but different equation. Now here also I have kept first 2 choices related to bandwidth and other 2 choices related to power of FM signal. All of you give it a try. This is the most interesting question. Some of you might be wondering that just now only we have discussed similar question. How, sir, how you are saying this is the most interesting question? Okay, I will disclose why I have mentioned this question is very interesting. In some time I will discuss. Okay, so all of you give it a try. This is a very beautiful question and interesting question. See, parameters wise, whatever I have asked in the previous question, same only. But there is a twist in this question. Okay, I will disclose that twist in some time. Yeah, I know that most of you are getting the answers for this question as A and C. A and C. Some of you might be getting A and C. You feel that is correct, but for this question, A and C are not correct. That is a twist in this particular question. Why option A and option C are not correct, I will discuss. Okay. Right. See here, they have given one FM signal like this. Okay, since we are having similar format in the earlier question also, I am not writing the standard equation. Okay, directly you can write, just compare the given equation with the standard equation. From there you can write directly the parameter values. Okay, so here AC value is 20 volts, AC cos 2 pi FCT, FC equal to 10 power 6 H, which is nothing but 1 megahertz, and AC cos 2 pi FCT plus beta value is 0.3, sin 2 pi FM into T. So here FM equal to 10 power 3 H, so which is nothing but 1 kilohertz. 10 power 3 H, 10 power 3 we can write as 1 kilohertz, right? Okay. Now, here you got the data, just like earlier question, you got the data like this. Okay, the moment you got, some students are in hurry mode, right? Okay, they don't bother what is the given FM signal, whether it is narrow band or wide band. Okay, whoever in hurry mode, they will assume that the given signal is wide band FM. Whatever earlier formulas we have discussed, blindly they will apply. That is the reason. Because of that, for this question, you will get option A and option C. But option A, option C are not correct. The reason is here beta value is 0.3. 0.3, this value is less than 1. So whenever you are getting modulation index values less than 1, that indicates narrow band FM. This is the twist in this question. That is the reason I have mentioned this is the interesting question and there is a twist in this particular question. This is a twist. In the previous question, beta value greater than 1, that time what are the formulas we have discussed regarding bandwidth and power, those are applicable. But the moment if beta is less than 1, you are having different formulas for narrow band FM, right? So here beta is less than 1, so it indicates narrow band FM. So whenever you are having narrow band FM, so the bandwidth of FM signal in the narrow band FM, the bandwidth of FM signal. For wide band, we have considered 2 into beta plus 1 into FM. But for narrow band FM is similar to your AM signal. So, for AM signal, the bandwidth is nothing but 2 FM. Similarly, the narrow band FM signal also, bandwidth is 2 FM. The only difference between narrow band FM and AM is, in AM, all the impulses you are getting values positive, whereas in the narrow band FM, regarding the lowest sideband impulse, you are getting negative signal strength. Okay, that is, or in other words, we can say that we are getting, regarding LSB, we are getting 180 degrees out of phase when compared to the AM signal. Okay, that is the only difference. Okay, so the bandwidth is nothing but 2 FM. So that means regarding narrowband FM and regarding AM signal, the formulas will remain same regarding bandwidth and regarding power required for transmitting signal. Okay, so bandwidth equal 2 into FM. So here FM value is 1 kilohertz. So that means you are getting 2 kilohertz. Okay, so 2 kilohertz here you are having in option B. But some of you got option A. The reason is some of you applied the formula like this. Bandwidth equal to 2 into beta plus 1 into FM. So here in this question, beta value we got 0.3. So 0.3 plus 1 into FM. So 1.3 into 2, that is nothing but 2.6. Here FM is nothing but 1K, so you are getting 2.6 kilohertz. But this is wrong. Okay, because beta value is 0.3, it is not greater than 1, right? That is the reason. But some of you might have used this formula. Because of that, you are getting 2.6 kHz. That option intentionally I have kept, that answer intentionally I have kept in option A, right? But option A is not correct. Option A can be correct like that formula 2 into beta plus 1 into FM you can use, provided if beta value is greater than 1. That model we already covered in the previous question, right? Fine. Next one is regarding the power of FM signal. Power of FM signal. So some of you used the formula like this. Power of FM signal is PC, which is nothing but AC square by 2. So AC value here in this question you are having 20 volts. So 20 whole square divided by 2. 20 square is nothing but 400 divided by 2. That is nothing but 200 watt. 200 watt. Right? See, this answer I kept in one of the options. Option C. But that is wrong. Option C is not correct. Because beta value, once again, the same case. Okay. Here, since beta value is less than 1, this approach regarding bandwidth is wrong. This approach regarding to calculate power is wrong. Now, what formula we have to use, sir? What formula we have to use? It is very simple. Whenever you are having narrowband FM, as I mentioned earlier, regarding the bandwidth, whatever the formula you have used with respect to AM, similar formula you got, right? 2 times FM. Similarly, regarding the power, whatever you have used in AM signal, similar formula you will get for narrowband FM. Here, power in narrowband FM. In the AM, you have used the formula as, just for reference I am mentioning here, in AM you have used the formula as PT equal to PC into 1 plus mu square by 2. PC into 1 plus mu square by 2. Right? PC into 1 plus mu square by 2. Similar equation here you are going to get. PC as it is, 1 as it is. Now, here in AM we have used the modulation index as mu, whereas in the FM we have used the modulation index as beta. So that is the only difference. 1 plus beta square by 2. PC into 1 plus beta square by 2. Okay, right. So here you can split into 2 terms like PC plus PC into beta square by 2. So regarding PC, just now, here we calculated PC, right? Just now, 200 watt. This value we can substitute here. 200 plus. Here PC value once again 200 divided by 2. Here in this case, beta value is 0.3. 0.3 whole square. 0.3 whole square. So here 200 times. 100 times. Here 200 you can keep as it is. Here 100 into 0.3 whole square we can write as 0.09. So 0.09 into 100 is nothing but 9. 9 plus 200 is nothing but 209 or 209 watts. 209 watts. Okay. Right. So that means option D is the correct answer. So for this question, if you have blindly followed the wideband FM equations or formulas, because of that you may get option E and option C, but those are not correct, because here in this question beta value is 0.3, which is less than 1, right? So whenever in the question, if they don't mention whether it is narrowband FM or wideband FM, so whatever the FM equation here they have given, just by comparing the given FM equation with the standard equation of FM signal, from there you can get the beta value. If beta value is greater than 1, that is wideband FM. If beta value is less than 1, it is narrowband FM. So accordingly, the moment if narrowband FM, so whatever the formulas regarding bandwidth and power which we got in AM signals, similar formulas will applicable. Whereas if you are getting beta value greater than 1, so that means it is a wideband FM. Whatever the formulas we have discussed just before this question, those formulas you can use for the wideband FM. I hope all of you are getting the clarity. These are the very minute things and very, very important. If the students in the exam, if they are in hurry mode, okay, see, for one case, whatever the formula you are supposed to apply, if you are applying that formula in another case, that means completely wrong, right? Completely wrong. That's why whenever you are remembering any formula, you try to remember in a systematic way. Which formula for which case we have to apply. You should know. Otherwise, Just simply by hearting the formula, no use at all. Because whatever the formulas you're having, you should know for what case, which formula we have to use, right? Okay. I hope all of you, whatever the learnings you're getting from this particular GATE score booster session, definitely making a significant role in your coming GATE exam. All of you, I hope all of you can avoid whatever the silly mistakes in general the students will do during the exam time regarding communication system subject while they're attempting questions. Okay, so all of you can overcome those silly mistakes regarding communication system subject, whatever the learnings you're getting with this GATE score booster session. So all of you try to avoid similar kind of silly mistakes in other subjects as well. Okay. Yeah, next question. So here also this question is MSQ. Here you can observe, choose the correct option or options. Okay. So here Fi is nothing but instantaneous frequency. Here I have labeled Fi max and Fi min. So that means it is the maximum instantaneous frequency and this is the minimum instantaneous frequency. Regarding that I have given the relations like ratio of maximum and minimum, two choices I have kept, and other two choices I have kept ratio of minimum and maximum. Okay. So here you are having FM signal. First of all, try to find out instantaneous frequency. From there, calculate maximum instantaneous frequency and minimum instantaneous frequency. After that, you can substitute. Okay. Among option A, option B, at max one option can be correct. Among option C and option D, at max one option can be correct. All of you give it a try. Yeah, time up. Whatever the answers you're getting, you can mention in the chart. So here in this question, you're having FM signal. We have to calculate the instantaneous frequency first. Okay. So first of all, I have copied the given FM signal. Whenever you're having FM signal, okay. So in general, you can represent the overall signal in the simplified form like this. So that is S of t equal to AC into cos. Earlier we have discussed in the standard format like 2 pi fct plus beta sine 2 pi fm into t. Okay. Now whatever here you're having, this overall term in simple form, you can represent like this: cos of theta of t. Cos of theta of t. Okay, AC cos theta of t. Okay, so this entire term you can represent as angle term. Okay, now in this question, first of all, we have to find out the instantaneous frequency Fi, right? So instantaneous frequency is nothing but 1 by 2 pi into d theta of t divided by dt. So that means you have to multiply 1 by 2 pi with the derivative term. Differentiation of theta of t with respect to t, that particular term you have to multiply with 1 by 2 pi. So from there you are going to get the instantaneous frequency. Okay. So here 1 by 2 pi we can keep as it is. Now d by dt of, now in place of theta of t, this entire term you can copy now. Okay. So here you will get 2 pi into 10 power 6 t plus 10 sine 2 pi into 10 power 3 t. Right? Okay, 1 by 2 pi you can keep as it is. Now, here you are having sum of two terms and we are performing differentiation operation. So we can perform individually differentiation. After that, we can perform sum together like that. Okay, because differentiator here you are having first order, right? Okay. So here 2 pi is the constant. 10 power 6 also constant. So we can keep as it is. 2 pi into 10 power 6. And dt by dt is nothing but 1. Differentiation of t with respect to t is nothing but 1. Plus. Here 10 is the constant, we can keep as it is. Now, derivative of sine term. Derivative of sine is nothing but cos. Here you are getting 2 pi into 10 power 3t. 2 pi into 10 power 3t. Now, here you are having 2 pi into 10 power 3t. So, for this you have to perform differentiation. So, here 2 pi into 10 power 3 is the constant that we can keep. And then differentiation of t with respect to t, once again you will get 1. Okay, so 2 pi into 10 power 3. Now here you are having 2 pi, right? So here in these two terms, if you observe, in the numerator you are having 2 pi. So if you are taking 2 pi as common, 2 pi will get cancelled. So after that you are going to get 10 power 6 plus 10 into 10 power 3, we can write as 10 power 4 and then cos term. Cos 2 pi into 10 power 3 t. Cos 2 pi into 10 power 3 t. I hope it is clear up to this point. Okay. So this is the instantaneous frequency. Now, just like in the one of the earlier question, in the beginning question of this particular session, we have discussed with respect to amplitude modulation. There we have considered AM signal. After that, regarding the envelope of the AM signal, we have considered the maximum voltage and we have considered the minimum voltage on the positive amplitude axis, right? Similarly here, you are having the instantaneous frequency equation like this. In this entire equation, 10 power 6 is constant, 10 power 4 is constant, 2 pi into 10 power 3 is also constant. Here, cos term you are having, it is a function of time. So once again, whatever the logic we have applied there, similar logic once again you can apply. Whenever you are having cos signal always will vary between -1 to +1 regarding the cos value I am talking, right? The minimum value is -1 and maximum value is +1, right? So accordingly, if you are substituting minimum value here, obviously overall value that you are going to get, that is the minimum. Similarly, if you are considering cos value as +1, overall value you are going to get maximum, right? So now I am writing Fi max, instantaneous frequency max. So which is nothing but 10 power 6 plus 10 power 4. 10 power 6 plus 10 power 4 by considering cos value as +1. Okay. So from here, you can take 10 power 4 as common. Then 10 square plus 1. So 10 square is nothing but 100 plus 1, which is nothing but 101. So you are getting 10 power 4 into 101. Okay. Similarly, regarding Fi min or instantaneous frequency minimum, which is nothing but here 10 power 6 you can copy as it is. 10 power 6 you can copy as it is. Now just observe. Cos value minimum is minus 1. So minus 1 into 10 power 4 is nothing but minus 10 power 4. Minus 10 power 4. So just like here, you can take 10 power 4 as common. Then 10 square minus 1. So 10 power 4 into 10 square is 100. 100 minus 1 is 99. So in this case, you are getting 10 power 4 into 101. In this case, you are getting 10 power 4 into 99. Okay. Now let us calculate according to the given options. Okay. In two choices, you are having ratio of max and minimum. And in other two choices, you are having minimum and maximum. Okay. So for the time being, since option A, option B, you are having first one with respect to max and minimum. So accordingly, let us calculate. So here, Fi max divided by Fi min. Fi max divided by Fi min. So which is nothing but 10 power 4 into 101 divided by 10 power 4 into 99. So here in this case 10 power 4 will get cancelled. You are getting 101 divided by 99. So just do the calculation. How much you are going to get? Tell me. You can mention your answer in the chart. 101 by 99. So which is nothing but 1.02. So I hope all of you are getting this answer. 1.02. So here 1.02. Yes, we are having in option A. So obvious that is correct. So the moment if option A is correct, you can eliminate option B. See here actually this question is MSQ. But suppose if this question is MCQ. And if all the options regarding Fi max divided by Fi min and only one option you are having greater than one value and remaining all the options if you are having less than 1, straight away you can choose option A is the correct one. Because here just observe. Here just by observing here 10 power 4 into 101, 10 power 4 into 99. So Fi max divided by Fi min. So 101 divided by 99, right? So obviously just by observing these two numbers, you are going to get it is slightly greater than 1, right? So slightly greater than 1, whichever option you are having, that option you can choose, provided if the question is MCQ. But here we are having MSQ, right? So we don't know whether that given option is really correct or not. That's why we have to verify each and every option. That is the reason we have to do calculation completely. Okay. Now the moment you got like this, now whatever the value you got, you can make ulta or reciprocal, right? So Fi min divided by Fi max. Fi min divided by Fi max. So that is nothing but 1 divided by 1.02. Otherwise 99 divided by 101. Both are same. Okay, 99 divided by 101. So all of you please mention your answer in the chart. 99 divided by 101 or 1 divided by 1.02. Both are same. So in this case, you are getting the answer as 0.98. See, 99, 101, almost closer. Okay, if suppose both are 100 or both are 99, both are 101, you will get 1. But here slightly differ. Okay, from 100 it is less than 1 or 1 value less. From 100, 1 value is greater. So that means whatever the value you are getting, it is almost closer to 1, but it is not equal to 1, like that. Okay, so from here you are getting a clue. If the question is MCQ, just by observing the values in that way, without doing the calculation. Of course, you can do calculation, but definitely it will take time, right? Suppose if luckily, if in this case, if only one option is having the value less than 1, slightly less than 1, only one option, definitely you can choose that one without doing the calculation. Because here 99, 101, almost closer to 100. If almost closer to same value, that means you are getting approximated value as 1, like that. Okay. So here 0.98 you are getting, that means option C is the correct. So the moment if option C is correct, option D is not correct. So for this question, two choices are correct, option A and option C. Option A and option C both are correct. Okay. So this is regarding instantaneous frequency, maximum and minimum. Maximum and minimum. So in two choices I kept ratio of maximum and minimum. In other two choices I have kept ratio of minimum and maximum. Okay. So up to here we have discussed the questions regarding amplitude modulation and DSBSC, SSBSC, and then frequency division multiplexing. Those are all those concepts related to the first chapter. Similarly, regarding second chapter, we have discussed the questions regarding FM. Right, so we have discussed the questions related to wideband FM and narrowband FM regarding power calculation and bandwidth calculation. And after that, we have discussed one question regarding the instantaneous frequency, maximum and minimum. Okay. Now, I will show two more questions. Okay. So these two questions are homework. As of now, in this particular session, I am not discussing these two questions, but for all of you, I am giving these two questions as the homework. Right. So all of you kindly solve these two questions. Okay, we are having time till tomorrow 5 o'clock. Okay, so till then, whenever you get time, try to solve these two questions. This is the homework question. So in this question, you are having the, here just I am giving the hint, okay, whatever we have mentioned. Here the question is regarding the frequency modulation. You are having the message signal and carrier signal, but in this question, they have kept the frequency of the message signal as 1 kHz, but they are varying the amplitude of the message signal, okay, starting from 0 volts, okay. So here, regarding the wideband FM, so in few cases you will get the carrier, at the carrier frequency you will get the signal strength as 0, right? So here in this case it is mentioned that it was found that the carrier component in the spectrum is 0 for first time when AM equal to 2 volt. Okay, so with the help of this data, and you just recall regarding wideband FM, for what values of beta you are going to get the carrier component. That means at carrier frequency, the signal strength you are going to get 0. Okay, so among those beta values, first beta value you have to consider, and with the help of that, you can calculate the frequency sensitivity. That is the first part of the question. And whatever the frequency sensitivity you got, that you can consider in the second question. Here we are asking that, okay, now you have to find out the AM value in such a way that, the carrier component will be reduced to 0 for second time. That means for answering the second part of the question, you have to consider the next beta value at which you are going to get the, at the carrier frequency you are going to get signal strength as 0. Okay, so in this second question you have to calculate AM. So for solving this question, you should require the value of frequency sensitivity, that is nothing but KF. Okay, so regarding first question, you have to consider the beta value. For what value of beta you are going to get 0. First try to identify among all those beta values, first beta value you have to consider. Whereas for second question, you have to consider second beta value. Okay, so I hope all of you got the clarity how to solve this question. I have given the hint. All of you give it a try. Okay, next question is also homework. This question related to the receivers, AM and FM receivers chapter. This is also homework question. So for this question, I am not giving the hint. All of you give it a try. Okay, so this is the question based on receivers, superheated and receiver concept. So this is a very interesting question. Just read the question carefully, and whatever the knowledge you are having regarding superheated and receiver concept, try to use the formulas which you know, and as per the given context, you can choose the correct option. Okay, so after watching this particular session, whoever trying the previous question, this question, whatever the answer you are getting, you can mention in the comment section. Okay, all of you are having time till tomorrow 5 o'clock. Okay. So here I am once again I am announcing whoever missed earlier. Okay. So in our IMS Gate Academy, we are providing GATE live online program for 2025 and 2026. Whoever targeting the GATE exam for 2025 and 2026, all of you, okay, they can just book the free counseling session regarding this particular link. It is provided in the description. So you can book the slot. Our counselors, they will guide regarding our program complete details. Okay. But as of now, I am giving the program features, the main important features. Okay. So here whoever enrolling for live online program, all the students, they are able to get 800 plus hours of live online class here in our online classes, just like currently we are teaching in the YouTube, right? So similarly, whoever enrolled for live online program, okay, so our faculties will discuss each and every concept from the basic level to the application level, and we will discuss variety of questions from the easy level, then medium level, and then tougher level. Okay, we will discuss the practice questions and we will discuss the GATE questions. So from our classes, live online classes, all the students will get the clarity about the concepts and how to solve the questions, right? After that, we are going to provide for all our live online program enrolled students, we are going to provide theory book for every subject. Similarly, exercise book for every subject we are providing. So all the students, they can access the theory book and they can practice the exercise book questions so that they will get the command over the concepts, and whatever the problems they might be facing, they can ask the faculties in the next class, or they can post their doubts in the LMS portal. Our faculty team will provide the detailed solutions so that in their preparation, wherever they are facing challenge, they can, our faculties will support through the doubts portal, and even in the live sessions, after every session, we will provide dedicated time for clearing the students' doubts. Okay. And in addition to that, we are providing the GATE question bank, which consists of more than 30 years, and our specialty of our GATE question bank is for whichever question, based on the possibility, we have provided the alternate solution and we have provided the key points or important points, so that each and every student, whoever solving the questions from our GATE question bank, they are getting thorough knowledge regarding the solution part, how to solve the GATE question, and they are getting good knowledge comment over the concept. Okay. And in addition to these two, we are providing online test series. Here for every chapter, we are providing one test, and similarly for every subject, we are providing basic test and then advanced test. After that, multi-subject test we are providing. After that, we are providing all India mock tests as well, right? Together, we are providing 130 plus online tests. So all the students, whoever enrolled for live online program, initially they will attend our classes, and parallelly they can practice the exercise book questions and GATE question bank, etc. After that, in order to get the confidence, in order to check their confidence about the subject, whether their preparation is up to level or not, whether they have to